collect the sample. So from the sample, we either get the z statistic, if we're talking about proportions, or we get the t statistic, if we talk about means. Either two populations, one population, it doesn't matter. Based on these numbers, so let's say this is number A. Did I lose you? No, I think I didn't. Okay, so whatever. I'm illustrating, it's the same thing I'm illustrating for one. And of course, we have to decide upon alpha. Let's say alpha is a number B. So then when I draw, and I can always do that with a graphing calculator, if alpha, let's say, is this area, so this is the B, and the z statistic, maybe I should say, for every z statistic I can, or t statistic, I get a p-value. Maybe that's better. The p-value is A, because that's what you're asking. I just wanted to make sure you understand where the p-value is coming. P-value is coming from either z or t. Okay, and I'll illustrate with graphs all the time on all the problems we do today.
And the p-value has to be the tails, right?
Yes, it could be one tails or two tails, right? But yes, the p-value could be a number greater than B, because right here I have the z statistic. So what you have in red here is the p-value. Because the z statistic is in the non-rejection area, obviously the red area is bigger than the black area. So the p-value in this case is greater than B, or greater than alpha if you want, same thing. So I have to fail to reject. So this is fail to reject, because the again, the p-value is bigger than alpha. So this is A is bigger than B. When A is bigger than B, the red greater than black, then I have to reject, fail to reject. Okay, so again, the p-value comes from the z statistic. If the z statistic, however, that's a second option. Okay, so let's say this, same thing. I have B. This is B. But now the test statistic falls somewhere here. I'm going to put a z statistic here. Look what happens to p-value. This becomes the A, the p-value. So A is much smaller than B. In other words, the p-value is smaller than alpha. So since the z statistic failed in the rejection region, not in the non-rejection region. So this is the non-rejection region. This red area is the rejection region. Since the z statistic coming from the sample, it has a formula. It's calculated based on the mean and the standard deviation of the sample and the sample size, as we know, right? So because the z statistic fell here, the p-value is this tiny, much smaller than alpha, which is the level of confidence. So then we have to reject the null hypothesis. Is that better?
Yes.
Other questions on this? Sorry about that. Other questions on this? Okay, then I'll go back to 11.1. And as I said, when only few of you were in the Zoom session, only 3 students are working in chapter 11. It broke my heart to see that. Okay, so I'm sharing my screen. And we are in 11.1 and 1.6. And according to my notes, Am I correct? This is what I have in my notes, 4 through 7 and 14. That's what we did not cover. Correct? Can anyone confirm?
To read I think that's right.
Good. So let's continue with 4. Of course, if you have any questions, I'll work on any problem. We'll work on any problem you need. Okay. So who would like to help with this one? Evan, are you with us? Can you help with us with this? Help us with this?
Yeah, I'm here.
Yeah. Okay. I have to tell you that the entire semester this happened to one other class once. I have no idea. Is that a sign? Why it happens to this class? I have no idea. So sorry. But I was patiently waiting for you to show up again. Okay. Thank you for waiting, for being patient. Okay, Evan, are you helping us with this?
Yeah, I'm trying to. I'm just slightly behind, but I'll try to get it going.
Well, we'll work on it together.
Okay.
Okay, will you read it for us?
A school psychologist wants to test the effectiveness of a new method of teaching French. She recruits 300 second grade students and randomly
divides them into 2 groups.
Yeah, sorry, I had to move the.
That's okay. Yes, sure. So let's stop for a moment. So we have 300 students, and she randomly divides them into 2 groups. Very important to remember that. Okay, 300 students, randomly divides them into 2 groups. Okay, let's continue.
Group 1 is taught by means of the new method, while Group 2 is taught by traditional method.
Okay, so we have a control group. The control group is the old method, which is Group 2. And this is the treatment group. Group 1 is taught by means of the new method. So this is our treatment. They're both treatments, but this is our treatment, and this is the control group. So Group 2 is the control. Group 1 is the treatment group. Good, awesome.
I think it's D then.
So the same teacher is assigned to teach both groups, meaning why? So there is no bias, right? Because if 2 different people are teaching these 2 classes, then we cannot control for the style, the teaching style of the professor, right? Good. So at the end of the year, an achievement test. So an achievement test is very important. Is it okay? So what is the response variable in the experiment? It's the scores on the achievement tests on both Group 1 and Group 2. Good. Okay, I agree. Everyone agrees with A?
Yes.
Perfect.
Yeah.
Okay. Now the response variable. An achievement test graded on the scale such and such is administered, and the results of the 2 groups are compared. So, is the response variable qualitative or quantitative?
Quantitative.
Right, because it says graded on a scale from 1 to 10. And it's a test. Good. So then?
It's also A.
Quantitative because it is a measurement. Okay. Because it is a characteristic. Very good. Agreed. I hope everyone agrees with that. Good. Which of the following explanatory variables is manipulated? Manipulated here does not mean that we are faking anything or tricking anybody, right? We're talking about the treatment. Okay, so when they say manipulated, they're really talking about the treatment. Which of the following explanatory variables is manipulated?
The method of teaching.
Method of teaching, of course. We don't want the teacher is the same. The grade level doesn't mean anything. The intelligence level doesn't mean anything. So we cannot, you know, change those. Good. And now what are the treatments? And how many treatments are there?
I would say B.
Yes, I completely agree. The treatments are the new method and the traditional method. Okay? Because they are separated, 300 students are separated into groups. Very good, awesome. The treatment is not the teacher, the treatments are not the students, and the treatments are not the groups. No, the treatment is what you give. It's a medicine or if it's a teaching method. Good, awesome. How are the factors that are not controlled dealt with?
Random assignment.
Exactly. That is the key word. Because here we're talking about students who have more skills versus students who don't. Maybe some students are speaking French at home. They will not compare to me. My French is not as good, right? So, but the random assignment, that's it. That's the key word. Excellent. Which group serves as the control group?
Group 2.
Yes, excellent.
Because they're using the normal, like the traditional method.
Correct. Yes. So if we read B, because the group corresponds to the new teaching method that is being tested, we already know that this is wrong. And the other ones are talking about group 1. So obviously, group 2 serves as the control group because this group corresponds to the standard method that will be compared to the other method to see, okay, is the new method improving students' scores or is not? Should we go for it or not? What type of experimental design is this? And this is a completely randomized design. It's not a controlled study. It's not matched pairs. In matched pairs, again, what a matched pair would mean is you take my blood pressure before I start exercising and when I finish exercising. So those are matched pairs. And that's not the case. And this is not a randomized block design. Is there more? Okay, identify the subjects. Perfect.
The 300 students.
Yes, of course. We already know the information is right there in front of us. Great job. Thank you. Good. So now they're asking us to draw a diagram to illustrate this design. Okay, so we started with 300 students. We separated them into group 1 and group 2 randomly. No one picked better students, students with better skills in French or lower skills in French. They were random. So this was group 1, they got the new teaching method. Group 2, they stayed with the traditional method. And at the very end, we compared their test scores on a scale from 1 to 10. Now in figure 2, it says, that's the block design, right? So they selected group 1 and selected group 2 randomly, but then they split group 1 into 2 parts. In group 1, some of them got the new method and some of them got the traditional method. In group 2, in the control group, some of them got the new method and some of them, the rest, got the traditional. And then at the end, we compare these two, their scores. and these two, their scores. Is it the first situation or the second situation?
I think it's A.
Of course, we did not, nobody says that we took group 1 and separated them into 2 groups and took group 2 and separated them into 2 groups. No, we did not do this. We used the scheme of the simple random, right? Good. Okay, question 5. A sampling method is when an individual selected for one sample does not dictate which individual is to be in the second sample. If you take my blood pressure before I start exercising and when I stop exercising, that is a dependent sample, right? But if you select, of course, qualitative and quantitative has nothing to do. A sampling method is not qualitative or quantitative. It can be, a sampling method can be independent or dependent. If you're not selecting me in the first sample and in the second sample, then it cannot be dependent. It must be independent. So a sampling method is independent when an individual selected for one sample does not dictate. See, if you select me and take my blood pressure before and after, then you have no choice. You have to take me in the second sample. And that will be dependent. You have to select me in the second sample. You have no choice, right? But here, an individual from one sample does not dictate which individual is to be in the second sample, and that is independent.